Good afternoon. My name is Charles Scott from Civil Designer Software. Thank you very much for allowing the time to join us today, and welcome to this month's Open Classroom webinar, the 73rd in our Civil Designer Software Open Classroom webinar series. This series forms part of Civil Designer's long list of support services found on our website's Services pull-down menu, where we have listed all our past Open Classroom webinars facilitated by Andrew Cole, Cameron Boyle, and Christopher Smith. While here, please visit the FAQ page, which now hosts around 420 short, searchable videos created from our past webinars. So, in the search bar, if I type in BIM, the following 7 videos are listed, detailing and demonstrating Civil Designer's interoperability and collaboration with programs like BIM Vision and BIM 360 via IFC and DWG, Allplan, where we export 3D road alignment strings for bridge deck design, and the 3 ways data can be shared with Revit via a Revit shared reference point, using a direct live dynamic DWG link, and exporting IFC files to Revit. Or I can type in 3D or support, where the following 6 videos are listed explaining how best to utilize Civil Designer's support services. Or I can click on the module icon, which will then list all the videos related to this module. Some inside info here. Next month, there will be a new addition to this module icon row. More I cannot divulge right now. An additional service which we have recently upgraded is our training platform, where we offer both free, on-demand introductory training, which is great for onboarding new staff members, as well as our CPD accredited intermediate training modules purchased as required module by module, also available on demand. So please feel free to browse through our website and contact us at any stage should you require any additional information. Back to today's webinar, where we welcome back Cameron Boyle, who many of you will know well from our support center, the many training courses he has facilitated over the years, and our past webinars. During Cameron's time today, please feel free to use the text chat service on your GoToWebinar app or web page to ask us any questions you may have during his presentation. After today's webinar, we'll post a video copy on our website in the webinar section. So, good afternoon again, Cameron, and please take it away.
Thank you, Charles, and good afternoon, everybody. Welcome to today's webinar. We'll be looking at Civil Designer's road templates. Templates are an integral part of any road design. Essentially, this is where we define how the road will react in different cut and fill conditions. The dimensions specified in the template dialog are not the final overall dimensions, but rather dimensions that will be used in the initial template for testing purposes. These dimensions will be superseded by edge level control spreadsheet. When the road width changes due to lane widening or the crossfall grade changes due to super elevation, it is not required to specify a different template. However, if need be, Civil Designer caters for up to 200 different templates per road, and additional templates can be added to the extremities of templates already applied. In front of us, looking at the carriageway setup, this is where we specify if we are designing a single, dual, or dual-crowned carriageway template. These dimensions are customizable. As an example, we currently have 3 meters from the road edge to the pivot point. We've got a negative 4% grade. These pivot points can be positioned anywhere along the dual carriageway cross-section and are used in conjunction with the vertical alignment elevations. I will discuss the cut-fill testing offset in more detail later. We'll look at the different tabs positioned in and around the template editor dialog, taking a closer look at curbs, where we can either select from a library of curbs or create our own. Looking at the pavement layers, where we have the option of utilizing the TRH4 pavement designer or create a pavement type of choice. Median information if we are doing dual carriageway designs. Looking at the old school way of inputting data information. The different display options available that can easily be changed. I'll also briefly explain how we go about utilizing these components on the left hand side. If you'd like more information on components, please refer to our YouTube channel for previous webinar content. As can be seen, the template can be viewed as a whole. Alternatively, we can focus in on the different design aspects. For example, right-click and select Show Current. On the left, I'm going to select Left Compulsory. We can then observe what is classed as the left compulsory condition. Take note, selecting lower median. Even though displayed in the template, the left-hand side carriageway is lower than the right-hand side. It doesn't necessarily mean that this will be the case for the entire design. The left and right carriageway heights will be picked up from the vertical alignment, and the applicable lower or higher median breakpoint conditions will be applied. Only if both median breakpoints are at the same elevation will the lower median condition be applied to the left-hand side, and the upper median condition will be applied to the right-hand side. I'm going to select the left cut condition and then using the mouse wheel to browse through the different cut scenarios. Same applies to the fill conditions. We can copy the left-hand side information and mirror the information to the right-hand side. Once the template is complete, we could save it, and at a later stage we are able to load it for another road design or even another road project. We also have the option to print. In that case, the text file of the different template assemblies will be created. I'm going to close this template as we will be creating a new one shortly. In Civil Designer, when creating a new road, go to File, select Road File. Click on Add Road button, which will then take us to the control panel. Specify which template to use and the preview gets updated, giving us a good idea of what the template looks like. Civil Designer picks up the initial template dimension and populates the below information. We can override these dimensions and specify specific curbs. One of the reasons why we are given the option to specify a template from the start of our road design is so that when we use the regression functionality, Civil Designer applies this specified template during the quick design process. If we do specify a template here, Civil Designer will automatically go to Tools, Template Paths, and populate the template path. If you're wondering about this function here of calculate areas, this is specifically for templates that we use in bridge design. Previously, we went through a process of copying the ground cross-section to the design cross-section so that there were 0 volumes at bridges. That's no longer necessary. We can simply just switch this option off. Let's take a look at an example of a template used for bridges. On the left-hand side, we could give our template a specific name, and that would be displayed in the Edge Control spreadsheet. We can then right-click, select Template Editor, and this will take us to the template ready for editing. In this example, there's no cut and fill information required, and the guardrails are inputted as compulsory components. Closing the template. For further explanation purposes, I'm going to select the main road. If we go to Alignment, Edge Levels, Edit Super, this is where we can specify which templates to use at specific chainage ranges. In order to implement these templates in the road design, we can then go to Area Volume, Apply Template. Let's design a template from scratch. Go to Tools, Template Editor. Let's make the dialog bigger. I'm going to right-click and turn off the automatic ground display. At the bottom of the dialog, select which display settings to use. Take note, I've specified a horizontal spacing of 3 meters and a vertical spacing of 2 meters. Bearing that in mind, if I select the carriageway tab, I'm going to put in the left and right carriageway width as 3 meters and have a -4% slope. The -4% is to emphasize that we have a camber condition. Specify left and right testing offset of 1.5 meters, and I'll explain this in more detail shortly. Starting off on the left hand side, I've gone and specified a left compulsory as my active assembly. Going to the data page, you'll see that the left compulsory tab is automatically selected. Here we could specify the horizontal and vertical movement. Horizontally, I'm moving 1.5 meters. Vertically, I'm keeping the previously stated -4% slope, so I'll insert a -0.06 meters value. This means that from the edge, I'm moving horizontally 1.5 meters and then vertically going down 60 millimeters. Before we review the outcome, I should point out that we have two additional functions we can utilize here. The first being an ID point. For cross-sectional roads, you can use the ID to display specific features in plan. The ID can also be used as a reference point for cross-section plotting of annotation and symbols. The second function being the point control function. Point control is a point indicated on the cross-section of your template. You can then modify that point horizontally or vertically, targeting a CAD entity or an existing road string in the plan view, as per your rules specified. If you'd like more information on this powerful point control functionality, please refer to our YouTube channel for previous webinar content. Back to what we have in front of us. Once I click on OK, look at the updated cross-section. Because this is a compulsory point, it means that this will always be applied to the road irrespective of whether we are in cut or fill. Alternatively, if I don't want to use the data spreadsheet, I go and delete this edge. Press Escape and select Add Edge option. Here again, I specify the horizontal movement, and instead of specifying a vertical dimension this time, I'd rather use a special vertical movement code. And in this case, I'm going to select crossfill grade. If we use this crossfill grade in the data page, a special movement code of 777 is specified. This would imply that if our road super elevation changes, so will the grade of the compulsory point. If I right click and select predefined ground, left cut, the compulsory point is applied to the edge, and then we have an embankment to the ground line. Same thing if I right click again, select predefined ground, left fill. The compulsory condition is again applied. As previously stated, the left hand side of our carriageway is currently in a fill condition. But for argument's sake, what happens if the ground does something like this? Which is highly unlikely, but for explanation purposes, I'm going to put the ground line in like this. As it is now, we are not quite sure whether we are in cut or fill, and that is why we need to specify where to test to see if the road is in cut or fill. That is done over here at the cut and fill test offset group. This would imply 1.5 meters from our last compulsory point. If we're looking at the display line, it's over here. This is the position to test whether our road is in cut or fill. We also have the option to allow to float. Let me discuss that option in more detail. If I right click and select add ground again and put in the road in a minor fill condition and a greater cut condition, I actually want the road to be treated as a cut condition. But looking at the cut fill offset, 1.5 meters is specified. That means that it will test at that point, and if that's the case, the road is actually in a fill condition. Civil Designer therefore gives us the option to allow to float. If we do select this option, Civil Designer won't just test at a fixed point, but rather test from our last compulsory point all the way through to our specified testing offset position. In other words, the test is conducted along an area and not just one position. Civil Designer will check our greatest fill condition and compare it to the greatest cut condition. In this case, the cut condition height difference is greater than the fill condition. Therefore, this is treated as a cut condition. Moving on, let's say the road is in a cut condition. What happens next? I'm going to right click, add ground. Selecting left cut, going to the data page, we can see that the left cut tab is automatically selected. Next, let's put in a V-drain. Horizontally, we move 1.5 meters. Vertically, going down, let's say -0.75 meters. Thereafter, we will apply a slope of 1 in 4 to the batter layer. That would go to the toe line of the ground. Let's see what that looks like. Click on OK. We have just inserted that side of the V-drain. Going back to data, from that point we've applied the 1 in 4 slope. Putting in the other side of the V-drain, going to line 2. As mentioned before, this is the older way of inputting the conditions. I'm using this method so that we can understand what the data page information represents. Once finished with the condition, we need to move the slope as well as the minimum maximum offset to the last used line. A 999 code is always needed to end off the final condition. This is the other side of the V-drain. We still have the 1 in 4 slope until we meet the ground line. You can imagine with very flat slopes, there's going to be problems with the embankment encroaching on someone's land. Therefore, Civil Designer has the option to specify a maximum or minimum offset from the center line or the road edge. In a scenario where the road reserve only extends to 12 meters on the left-hand side, we would preferably want the toe point to be at that 12 meter mark. I can go back to the data and specify a maximum offset of 12 meters from the center line. Looking at the cross section, if I click on OK, the grade has been updated. So that 12 meter mark is not exceeded. Currently, this condition is applied to the entire cut scenario. I'm going to change that and rather specify that if there is a cut greater than 2 meters of depth, then the V-drain needs to be replaced with the trapezoidal drain. Instead of doing this manually as before, this time let's use the components option. Let's add a new condition. Specify the minimum height this time of 2 meters. Leave the batter slope of 1 in 2. Instead of going to the data page, I'm going to browse through the components and select the trapezoidal drain. Left click, hold the mouse button in, move it to the red arrow, and then let go of the mouse button. That's a lot easier than going to the data page and inserting relevant information, but looking at the data page, all the information has been updated. You can see these cells have a gray background. That's indicating that it's a component that has been used. The minimum and maximum heights have also been updated. Selecting the template option on the left side, all components used in the template will be listed. I have the option of right-clicking and selecting Edit. If I do make changes here, then the dimensions used in the template will dynamically be updated. At this stage, it may be a good idea to explain the other vertical movement codes. Going back to add edge, specify the horizontal movement, and this time with the vertical movement, I'm going to change the option to previous grade. Civil Designer will then use the grade of the last edge of the trapezoidal drain for the horizontal distance of 1.5 meters. While this function is still open, let's change the vertical option to cross-fall grade. This implies that if the left carriageway grade changes, so will this parallel stretch of grade change accordingly. Lastly, I change this to ground intersect and make the slope 1 in 0. Civil Designer will then put in a vertical slope to the ground level. This is ideal when you want to model retaining walls with variable heights. Let's delete these options. We are not limited to just one component per condition. We can utilize numerous components. As an example, let's utilize some gabions. Selecting the appropriate gabion by left-clicking, holding it in, and then dropping the component in the correct position, letting go of the mouse. Alternatively, we can also right-click and select Add to Template. I've only been explaining the left-hand side. If we want to apply this to the right-hand side, we have the option of right-clicking, select Mirror, and then click on Assembly. Same thing applies to the compulsory option. Select it, right-click, Mirror, Assembly. Looking at the other tabs at the bottom, if we go to the Curbs option, we've got a wide variety of curbs to choose from. We can apply the curbs to the left and right-hand side of the single and dual carriageways. We are given the option to edit the curb, We can specify our own horizontal and vertical movements, and from this we can save our own set of curbs. Looking at the curb offset position, our road edge would be positioned where this face line is indicated. The stop position indicates the position of where we want the sidewalk to be. Selecting the Quantities tab. Quantities are customizable according to project requirements by right-clicking and selecting Define Region. Once done, right-click and give a description. Unit lengths specify the lengths of the actual precast curb units. The resultant curb units will be reflected in the export to IFC and in the render view. Unit lengths are defined in meters for a specified curb radius range. A value, as displayed here, will result in a continuous curb. As an example, we could make the minimum radius 4 and specify a unit length of 1 meter. That means that any curves with a radius greater than 4 meters will have curbs of 1 meter lengths. Save, close, and apply it. Next up, in the template design process, let's select the layers option. All layers will be applicable to single carriageways. If you've got a dual carriageway design, R layers will also be applicable. Under the layer description, right-click and select TRH4 pavements. This is built into Civil Designer by default. Here we select the pavement type, road category, and traffic class. If you're not too sure of the traffic class, we can input the relevant information and Civil Designer will calculate the most applicable traffic class available. Select the pavement design of choice and the layer description is populated. Shifting our attention to the left, looking at the layer depth, a default TRH4 value has already been inserted here per layer, but as designers we have the option to override this. Moving on to PLCs or point location codes. In much earlier versions of Civil Designer, you had PLC numbers. For example, PLC -1 would represent the left edge or the first point left of the center line. These codes can still be used, but we have made it easier by presenting a descriptive name. The left-hand side is represented by a negative, anything on the right-hand side is a positive. In addition to that, we can give the pavements a step or a shift, making the pavement layer wider in some cases. Let's take the left information, copy and paste it to the right-hand side. If you are doing a dual carriageway design, select carriageway. Here we select either dual crowned or dual. When dealing with dual carriageways, we also have the option of specifying median information, where we can input the horizontal and vertical movements and then specify which design we would like to allocate for the medians. If we select straight, the medians are joined with the straight line. Alternatively, if we select the slope option, we can, for example, put in a 45-degree slope, creating a V-drain. Right-click, select Add Ground. The V-drain will remain irrespective of where the ground is situated. However, if we go back to the median and we change the joint type to slope plus extract, that 45-degree will be applied until the ground level is intersected. We also have the option of using components on the left-hand side and applying it to the median. Another very nice function is to have the option of right-clicking and exporting the template to a drawing. In that case, Civil Designer would create a CAD drawing at the drawing scale of choice. Civil Designer would also insert and populate a pavement layer table. In a similar manner, we also have the option of importing drawing information and applying it to the template. I think we've pretty much covered everything. Please let us know if you have any additional questions. Until next time, cheers for now. Back to you, Charles.
Thank you very much, Cameron. That was great. And thank you very much to all of you who attended today's webinar. Please remember, if you would like any further information or assistance with regards to the contents of Cameron's presentation today, or if you would like to request future webinar topics, please use the email address listed on your screens right now. Please also remember we'll be posting a copy of this webinar in our website's webinar section. Finally, please follow us on LinkedIn for our weekly updates covering client showcases, civil designer related news, and new software video tech tips. Once again, thank you very much for your time today. Have a great afternoon, weekend, and goodbye for now.